I think I'm running within the time allotted, so at this point I just wanted to thank you all for listening. And again, time is short, but I point you to the future grid tutorials if you want to do some hands-on with these technologies, and also the Grid Appliance website if you'd like to learn more about these technologies. Thank you.
Yeah, so we need virtual applause. And it's open for questions. So I have a question, Renato. What are the next steps with appliances? Just more of them, or better technology or something?
Well, I think one important step has to do with standards and enabling appliances to be easier to move from different providers. Virtualization allows you to do these nice packaging of software into an image, but then you have to make sure that the image is able to run on a variety of platforms. And there's still idiosyncrasies. Amazon EC2 uses Zen technology. Google Compute Engine uses KVM. Others use VMware. And there are ways that you can convert images from appliances, but there's not yet a mechanism that makes it really simple to move appliances from different providers. That's a little bit under the hood, not on the appliance level itself. At the appliance, you can make your life easier by packaging things in a way that expects or the appliance itself is prepared to run on multiple infrastructures. Another aspect that performance is always important, and in the case of distributed grid cloud computing, it's always something to be aware of and consider. So appliances that are able to benefit from accelerators or to access high-performance devices like InfiniBand, or to bypass the virtual network in a local area network, or to access a graphics processing unit device. These are it'd be nice to have these capabilities again, be able to be packaged together inside a virtual appliance in a way that it's easy to run a virtual appliance anywhere, and it recognizes which devices are available and makes the best use of available devices. And also the process of automating the process of creating virtual appliances and keeping them up to date with patches there's work in this area, but it's still an aspect of appliances that can be improved.
Matthew has a question. Can you hear us?
Yes.
I'm curious whether if one wanted to study like network topology, like a double tree, fat tree network for redundancy, are these sort of virtual clusters useful for doing such studies?
That's a good question. I would say yes, if the virtual network allows you to configure the topologies. So in the examples that I gave previously, if you look at iPod, as a user, you're not able to configure the network. It configures itself, so you don't have that capability. But on Vine, for example, you can configure your topology. So if you would like to be able to experiment with your own virtual network topology, you should be able to do that kind of exercise. I'm not sure anybody has done that yet, so I would defer that to the Vine folks at UF, to tell you exactly which topologies you might be able to use. But that's a good use of virtual network virtualization. Yeah.
Okay, thank you.
Sure.
What sort of performance overhead do you expect in virtual networks?
Again, it depends on at what layer you're using a network virtualization software or hardware. I mean, if you look at OpenFlow enabled virtual switch network switches that support virtualization, the overhead is very small. Is that you have hardware level virtualization, and you're basically just looking at hardware pipeline that does packet matching and minimal changes to packets as they get through a switch. So the overhead there is very small. Now, if you're looking at software level virtual networks like the ones that I described today, software virtual networks have close. Vine, for example, has come close to gigabit performance. I quoted one example of a user-level router that gets 880 megabits per second on a gigabit Ethernet. The typical latency added by the virtual network would be of the order of sub-millisecond latency overheads. There are other projects that are looking at virtual networks that I didn't have time to talk about. I'm aware of another one at Northwestern University, VNet, and I know that they have implemented a virtual network at the hypervisor level with a high-performance hypervisor that is being developed at Northwestern, and I think they're getting very close to gigabit Ethernet also performance and working towards 10 gigabit Ethernet performance. But I think with multi-core machines and machines that can run the virtual router with high throughput, the overheads tend to be small. And again, the virtual network may be even bypassed if you do smart programming of the virtual network itself, or if you combine software virtual networks with underlying hardware virtualization like OpenFlow enabled switches. So that's just like virtual machines, people are working towards closing the gap between native performance and virtual machine performance. The same is ongoing for virtual networks.
Well, any more questions? Do we have a question over here from Indiana? Why don't you?
So my question is, we use the VM for not to run the science experiments, but use it for providing high availability services. Is one of those virtual networking technology actually reliable enough to start providing cross-site HA type infrastructures, or is it a complete out of scope for virtual network?
No, that's within scope. I mean, when you're talking about availability, you have to take into account, the availability of the physical network and then the virtual network. So you have additional chances of failure, right? Now we have a virtual network that the virtual router may fail, but the virtual network itself can have multiple paths. The IPOP virtual network, for example, we actually have demonstrated in one example the ability to route messages between two nodes that were not connected directly by the public internet. They had a public internet routing outage between two Planet Lab nodes. So machine A and B could not send a packet to each other, but they were able to send through an intermediary in the overlay. So this high availability is a little bit difficult to tell you exactly what is the availability that you would get from the virtual network itself, but the virtual network can be programmed to support multiple paths. So if you have routers that get to fail, you can reprogram the routing substrate to move around failures. But I'd have to, this would work again on virtual network addresses. If you're looking at a service that has a public-facing address, a public web server that's replicated, for example, the virtual network will not help you with the public network interface, but only with private network connections.
Okay, thank you very much.
Sure.
Okay, some wrap-up of applause. Thank you.
Thank you.